Welcome to DC Digital Learning Session. I am Dr. Shobhan Kumar DM, working as Assistant Professor in Maharani Science College for Women. Today we have to discuss how to solve the system of linear equations by using iterative methods. There are two methods here. One is a Gauss-Jacobi's method. Another one is Gauss-Seidel method. When the given system is diagonally dominant, then only we can apply Gauss-Jacobi's or Gauss-Seidel method. What do you mean by diagonally dominant? For example, given three equations in three unknowns. In first equation, coefficient of x is numerically larger than other coefficients like coefficient of y and coefficient of z. In second equation, coefficient of y is numerically larger than other coefficients. Like this, in last equation, coefficient of z is numerically larger than other coefficients. Then only we say that the system is diagonally dominant. If the system is diagonally dominant, we can go for either Gauss-Jacobi's method or Gauss-Seidel method. Today, I have to discuss about Gauss-Jacobi's method, how to solve the system of linear equations by using Gauss-Jacobi's method. Here, consider system of equations. A1x plus b1y plus c1z is equal to d1. A2x plus b2y plus c2z is equal to d2. A3x plus b3y plus c3z is equal to d3, in which numerically larger coefficients are along the leading diagonal. Here, this one, a1, b2, and c3 are numerically larger than other coefficients. Then only we say that the system is diagonally dominant. If system is diagonally dominant, we can use either Gauss-Jacobi's method or Gauss-Seidel method. Here now discuss about Gauss-Jacobi's method. Now sometimes we may have to rearrange the given system of equations to a diagonally dominant system. If this condition is satisfied, the solution exists as the iteration will be converged. From the given system of equation, we can write here x is equal to 1 upon a1 into d1 minus b1y minus c2, and second equation can be written as y is equal to 1 upon b2 into d2 minus a2x minus c2z, and from this last equation can be written as z is equal to 1 by c3 into d3 minus a3x minus b3y. Here, here the coefficient a1 is numerically larger than other coefficients, therefore we can write in this form. Here, coefficient of y is numerically larger than other coefficients, we can rearrange like this. And here, coefficient of z is larger, numerically larger than other coefficients, therefore we can write like this. The given system, we have to rearrange like this, x, y, z. Here equation 2, 3, and 4. Now, choosing the initial approximations of x, y, z. In Gauss-Jacobi method, we choose x, y, z are 0. X is equal to 0, y is equal to 0, or z is equal to 0. In general, x equal to x naught, y is equal to y naught, z is equal to z naught. Here, x is equal to 1 upon a1, d1 minus b1 y naught plus c1. Y is equal to 1 upon b2, d2 minus a2 x naught minus c2 z naught, and z is equal to 1 by c3, b3 is equal to a3 x naught minus b3 y naught. Here we getting x1, y1, z1. First, approximate values of x, y, z are x1, y1, z1 with initial approximations x naught, y naught, z naught. Here we get like this. After obtaining x1, y1, z1, substitute in 2, 3, and 4, we get second approximations or second iterative values x2, y2, z2. x2, y2, z2. The above process is repeated until any two consecutive iterative values are same. The solutions are obtained from the values in the last iterations. We note that in the Jacobi's iterative method, we start with some initial approximations x naught equal to 0, y naught equal to 0, z naught is equal to 0. Z naught is equal to 0. Z naught is equal to 0. If the initial approximation are not given, if given the initial approximation, we can use the given values. If not given, simply we choose x naught 0, y naught 0, and z naught 0. This is the process of Gauss-Jacobi's method to find the solution of given system of linear equations. Once again, I explain, you should remember, first check it, given system is diagonally dominant or not. If not, just rearrange and make it as diagonally dominant, and then rearrange, and then we can write down x1, y1, z1 with initial conditions x0, y0, z0. We get x1, y1, z1, and again with initial conditions x1, y1, z1, we get x2, y2, z2. Second approximation, same process is repeated until to get two consecutive iteratives or approximately same. Approximately same. Now we have to discuss some few examples. Solve the system of equations by Gauss-Jacobi's method. Gauss-Jacobi's method. 10x plus 2y plus z is equal to 9, x plus 10y minus z is equal to minus 22, and minus 2x plus 3y plus 10z is equal to 22. Here, the given system is diagonally dominant because in the system of equation, first equation, coefficient of x is plus 10 is numerically larger than other two coefficients. In second equation, coefficient of y is also 10 is numerically larger than other coefficients. In third equation, coefficient of z is also plus 10 is numerically larger than other coefficients. That means all the diagonal coefficients are numerically larger than other coefficients. Therefore, given system is diagonally dominant. With this, according to Gauss-Jacobi's method, the given system can be written as x1 is equal to 1 by 10, 9 minus 2y minus z, y is equal to 1 by 10, minus 22 minus x plus z, and z is equal to 1 by 10, 22 plus 2x minus 3y. Now with initial conditions, initial values, choose the initial values, x naught, y naught, z naught are 0. Therefore, this equation can be written as x1 is equal to 1 by 10, 9 minus 2 y naught minus z naught. Here instead of y and z, we put y naught, z naught, and here y is equal to 1 by 10 minus 22 minus x naught plus z naught, and z1 is equal to 1 by 10, 22 plus 2x naught minus 3y naught. Already we choose the initial values of x naught, y naught, z naught are 0. Put here and simplify. We get x1 is equal to 0.9, y1 is equal to minus 2.2, and z1 is equal to 2.2. These are the first approximate values of x, y, z. With this, we go for second iterations. Here x2 is equal to 1 by 10. Here already we know that here general equations. Here instead of y and z, y1, z1. Here x1, z1. Here x1, y1. With this, we get second iterations or second approximations values of x, y, z. x2 is equal to 1 by 10, 9 minus 2 y1 minus z1. y2 is equal to 1 by 10, minus 22 minus x1 plus z1, and z2 is equal to 1 by 10 into 22 plus 2x1 minus 3y1. Here we know that x1, y1, z1. These values put here, substitute and simplify. We get second approximations of x or x, y, z are x2, y2, z2. x2 is equal to 1.12, y is equal to 2.07, and z2 is equal to 3.04. These are the second approximations. We check it, first approximations and second approximations are not approximately same up to 4 decimal places, at least 4 decimal places or at least 3 decimal places. Now we go for one more approximation. Third approximate values with initial conditions are x2, y2, z2. Therefore, x3 is equal to 1 by 10, 9 minus 2 y2 minus z2. Now x3 is equal to 1.01. y2 is equal to 1 by 10 into minus 22 minus x2 plus z2. Here we know that x2, y2 here Therefore, y3 is equal to minus 2.008 and z3 is equal to 1 by 10 into 22 plus 2x2 minus 3y2. We know that x2 and y2, substitute here and simplify, we get z3 is equal to 3.05045. Therefore, third approximation or iterations are x3 is equal to 1.01, y3 is equal to minus 2.008, and z3 is equal to 3.04y. Now by using x3, y3, z3 in 1, 2, 3, 4, we get fourth iterations because here x2 and x3 are not approximately same, y2 and y3 not approximately same, and z3 and z2 not approximately same. Here we go for one more iterations, x4, y4, z4. x4 is equal to 1 by 10, 9 minus 2, y3 minus z3. We know that y3 and z3, substitute here and simplify, we get x4 is equal to 0.9971 and y4 is equal to 1 by 10 into minus 22 minus x3 plus z3. We know that x3 and z3 substitute here and simplify, y4 is equal to minus 1.9965 and z4 is equal to 1 by 10 into 22 plus 2x3 minus 3y3. We know that x3 and y3 substitute here, we get z4 is equal to 3.004. Therefore, fourth approximate values of x, y, z are x4 is equal to 0.9971, y4 is equal to minus 1.9965, and z4 is equal to 3.004. And by using x4, y4, z4, we get the fifth iterations. Here, fifth iteration, x5 is equal to 1 by 10, 9 minus 2, y4 minus z4, y5 is equal to 1 by 10 into minus 22 minus x4 plus z4, z5 is equal to 1 by 10 into 22 plus 2x4 minus 3y4, and substitute the values of x3, x4, y4, z4 here and simplify, we get x5 is equal to 0.9989, y5 is equal to minus 1.9993, z5 is equal to 2.998. Therefore, fifth approximate values are x5 is equal to 0.9989, y5 is equal to minus 1.993, z5 is equal to 2.998. Here by using x5, y5, z5 in 1, 2, 3 we get sixth iterations. Here sixth iterations are 1, x6 is equal to 1, y6 is equal to minus 2, z6 is equal to 2.99. And again by using these iterative values, we get one more iteration, seventh iterations, x7 is 1, y7 is minus 2, y7 is 2, sorry, this is 2. y5, here y6, here y7 is minus 2, and z7 is 3. Here this is a minus. Here the values of sixth and seventh iterations, comparing these two values are almost the same. Therefore, the roots or solutions of the given system of linear equations according to Gauss-Jacobi's method is 1, minus 2, 3. And another example, solve the following system of equations by Gauss-Jacobi's iterative method. Correct to 3 decimal places. The system of linear equations are x plus y plus 54 z is equal to 110, 27 plus 6y minus z is equal to 85, 6x plus 15y plus 2z is equal to 72. By observing the given system is not diagonally dominant, we make it as diagonally dominant by interchanging the equations. Here, in this system, second equation, 27 is numerically larger than other coefficients. That means here A1 is numerically larger than other coefficients. We take it as first equations in the system. And the second one is here in the last equation here 15. This is nothing but B2 is numerically larger than other coefficients. Therefore, take it as second equations in the system. And remaining last equation here 54 is numerically larger than the other coefficients. Then the equation becomes diagonally dominant. That means we can write on 27x plus 6y minus z is equal to 85, 6x plus 15y plus 2z is equal to 72, x plus y plus 54 z is equal to 110. This is diagonal dominant system. Now applying Gauss-Jacobi's method. From first equation, x equal to 1 by 27 into 85 minus 6y plus z. From this equation, second equation, y is equal to 1 upon 15 into 72 minus 6x minus 2z. And from this equation, z is equal to 1 by 54 into 110 minus x minus y. Now starting with initial values, x not equal to 0, y not equal to 0, z not equal to 0 in 1, 2, 3, we get first iterations. Here first iteration, already we chose x naught, y naught 0. With this, we get x1 is 3.1481, y1 is 4.8, and z1 is 2.0370. These are the first iterations or first approximations. With this, we get second iterations, then equations 1, 2, 3 becomes x2 is equal to 1 by 27, 85 minus 6, y1 plus z1, y2 is equal to 1 by 15, 72 minus 6, x1 minus 2, z1, and z2 is equal to 1 by 54, 110 minus x1 minus y1. Then simplify, we get x2 is a 2.1569, y2 is a 3.2691, and z2 is 1.8898. These are the second iteratives. By using x2, y2, z2 in 1, 2, 3, we get third iterations. Here, third iterations are x3 is equal to 2.4916, y3 is equal to 3.6852, and z3 is equal to 1.9365. These are the third iterations. And again, by using x3, y3, z3, in equations 1, 2, 3, we get fifth iterations. Here, fifth iterations are 2.4009, y4 is equal to 3.5451, z4 is equal to 1.9226. By using x4, y4, z4, we get fifth iterations. Then equation 1, 2, 3 becomes x5 is equal to 2.4315, y5 is equal to 3.5833, z5 is equal to 1.9269. These six iterations are x6 is equal to 2.4232, y6 is equal to 3.57048, z6 is equal to 1.9256. With these seventh iterations are x7 is equal to 2.426, y7 is equal to 3.573, z7 is equal to 1.926. And again with these eight iterations are x8 is equal to 2.425, y8 is equal to 3.573, z8 is equal to 1.926. Here by observing seventh and eighth iterations are approximately same up to 3 decimal places, up to 0.2 digits are same. Here x1 is equal to x8, y7 is equal to y8, z7 is equal to z8, up to 3 decimal places. Therefore, the solution is x is equal to 2.425, y is equal to 3.573, z is equal to 1.926. This is the required answer. And similarly, you can solve these equations. Already I solved this problem by Gauss-Jacobi's method. We get answer is 1.10015, y is 1.0020, and z is 1.0024. And I given here many problems as exercise. Do yourself, and these are the reference textbook. Thank you.